In my previous video, I showed you how to use localized topology to add details to specific areas of your 3D models without having to subdivide the entire mesh, allowing you to keep a reasonable poly count. In this video, I will show you 2 more examples and explain why this method is essential for optimization. These techniques work perfectly for both sub-D modeling and game assets. For the first example, I want to add circular holes to these 9 vertices while maintaining this level of subdivision. First, we can see that with the classic method of insetting 4 faces and transforming them into circles, we clearly don't have enough faces to create 9 circles in the center. To use that method, we would have to subdivide the mesh like this, but this is exactly what we are trying to avoid. To make it work, I simply added a bevel to the 9 vertices and deleted the faces. The goal is to increase the subdivision locally and contain the topology within the blue highlighted zone. This keeps the polygon density relatively low and uniform outside that area, so the faces remain square and consistent in size. To do this, we will start by connecting the corner vertices by pressing J. Then we will connect the vertices between each circle to create squares. This will allow us to add edge loops, which isn't possible right now because we have n-gons. Now let's connect the outer vertices all around the zone. We don't want to add edge loops that extend outward to connect the remaining vertices, because as I mentioned earlier, I don't want to touch the external structure of the localized area that would break the uniformity of the faces. Now let's add horizontal and vertical edge loops to double the polygon density within the localized area. The next step is to connect the vertices along the diagonals of the squares we created earlier, then delete the horizontal and vertical edges of these squares. Let's define a protection zone with the knife tool like this. To use it, press K, then A to ensure perfectly straight cuts. Using the knife tool again, we will connect the outer vertices of the circles like this to create diamond polygons. If you hold Shift while using the knife tool, you can create a vertex perfectly in the center of an edge. Do this all the way around the localized area. The last step is to connect the remaining vertices like this all around in order to eliminate the n-gons. Then delete the edges to remove the triangles. Select these vertices. Change the pivot point to bounding box center and scale inward to create a slight angle. And do the same with the remaining diamond polygons. This way we have quads everywhere and have successfully constrained the topology to the zone we defined at the start. We've kept a low and uniform polygon density. This approach ensures a fully quad-based mesh while keeping the topology strictly confined to the area we initially defined. The polygon density remains low and evenly distributed. It's an efficient way to add details without impacting performance or unnecessarily increasing the complexity of your 3D scenes. And now we can add bevels to each circle. Let's compare this with an identical model that is more heavily subdivided. At first glance, we can see that our optimized model has a poly count twice as low. In scenes containing many 3D models, this can make a massive difference in performance. Using this method, you can easily save thousands of faces. The best part is that this method does not affect shading, even on curved surfaces. If we compare the 2 models with a reflective matte cap, there is absolutely no difference between the high poly and low poly versions. The surfaces are perfectly smooth. And even with this matte cap, which highlights shading imperfections, the lines remain perfectly straight. You can download my beginner 3D modeling ebook called Mastering Topology and Hard Surface Modeling. It includes tips and tricks to work faster and more efficiently, the most common mistakes beginners make and how to fix them, and many other helpful insights. 13 years of experience gathered in one place. The link is in the description. In this second example, the problem is the same. We have details in the center, but we have very close edges that destroy the uniform size of the polygons. This is a very common mistake among beginners that should be avoided. First, we will delete the unnecessary faces, since the model is symmetrical. Let's start by removing this edge loop, then connect the corner this way. Let's delete this edge, then this entire loop, and connect the bevel like this. We can add an edge loop here between the 2 holes. Then we delete these 2 edge loops, connect the vertices like this, and dissolve these edges to get rid of the triangles. To reduce the topology further, select these 3 vertices, press M and choose Merge at Center. Select these edges, delete them, and move this vertex to the right to give this polygon a slight angle. Let's use the mirror modifier to bring back the bottom faces, then repeat the same steps with the edges in the center. Let's use the mirror modifier one more time to bring back the faces on the right. Now we will remove these edges that break the face uniformity, and then use the knife tool to create cuts like this. However, be careful because we created a 6-edge pole. This isn't an issue on a flat surface, but it can cause shading issues on a curved surface. If you look closely, the polygons are not perfectly the same size, so we can delete these edges and add a few less to make the whole thing more uniform. And that's it. If this video was helpful, please consider subscribing. It's free and you can always change your mind. Thanks for watching.